Hey, hello guys, welcome, vanakkam, vandanam, namaskaram. Today we are going to see mathematics. Okay, so continuity and differentiability. See, in this lesson, actually this is one of the most important lesson, and a lot of people are saying that this lesson is something that's very tough. But as we all know that if you just do enough hard work, then anything in this world will be easy, right? So we will try our level best to make this lesson as easy as possible. Okay, so continuity and differentiability. Before get going with this lesson, we have to discuss about a few terms. Okay, so first is limits. Before going to that, well, I have a lot of videos in stock. I don't know when you all will be seeing this video. I think when you are seeing this video, I may have reached like about 78 to 100 subscribers. I don't know whether will I or not, but I was kind of happy with the views count, even though the like count and the subscribers count haven't increased that much. But the views count has increased a lot drastically. I was kind of happy for that. So thank you for seeing on every videos, okay? And also I personally feel like if you have any doubts, you can ask me. And also there were a lot of good comments about four good comments about them. Three were very good, and one was about asking me to put video based on wave optics. Okay, so since I'm just a student, I cannot just teach just like that wave optics. I have to read myself, I have to understand every topic, then only I can post videos. So according to my school portion, we are just moving on. So yeah, so when it's the good time for me, I will be posting it. Okay, so coming back to the concept of limits. What is this limit? Already in our class 11th even we have studied, right? Limit is something, we can say that it is an approaching value of a function. We need not to know the definition of like limits at all. We just check it out. What's the limit? Okay. So I'll just take a graph. Okay, a graph like this, where in this what I'm going to do is okay, so in this is a graph and I'm going to write a function. See, very simple. I will just explain it from the beginning. Limit is a technique, okay? It is just a technique. So before that we have to know a function. What is a function? Function is very simple. Let us take that this is a machine. Okay, this is a machine. Egg machine. We will take it as an egg machine. So it can boil actually eggs. You can keep egg over here and then you can put water and you can just boil it out. Okay, so the input which I am giving over here is actually egg. Okay, so here you have kept the egg in everywhere. Okay, and then now you have closed. Now what you are doing is you are giving function. What is the function? That is what this machine is doing. The machine's function is to boil this egg. Okay, then after that the output will be the boiled egg. Okay, the output will be the boiled egg. So the function is the machine and the input is the egg. Okay, that is what the domain we will be saying, or that is what the x value we will be saying. Okay, and the class will be getting f of x. The y value we will be getting. The output we will be getting. Okay. So like that, see, every function has its own graph. Okay, so for an example, here I've got a function like this, which is f of x is equal to x square minus 4 by x minus 2. Okay, like this there is a graph. Oh, see, like this there is a function. This is an equation. So where if it is something like this now, then okay, in this whole page we are going to see just what is the limit, since it's very important. Okay, it's very important. We'll be just taking out what is a limit. Okay, so this is a function they have given like this. Now what I'm going to do is in place of x, okay, so x is equal to 1, I'm first going to do. That means how it will be f of x. You can also write f of x as y value. Okay, so I will write here as y. Y is equal to 1 minus 4 whole divided by 1 minus 2. Okay, because 1 square is 1 only. So 1 minus 4, which is 3 by 1. Okay, so here it is 3. Perfect. Then secondly, I'll be uploading here 3. Okay, f of x is actually 3 over here. So I say x is 3. X is 3. Then in that case, y is equal to 3 the whole square minus 4 whole divided by 3 minus 2. Like this it is. Then how it will be? It will be 9. 9 minus 4 will be, hey, here will be minus 3. Sorry, here it will be minus 3. Yeah. So here it will be minus 3. Here it will be 5 by 1. Yeah. So here it will be minus 1. Okay. So this and this will be cancelled. So it will be just 3. Okay. So it will be just, sorry. Okay. So here it will be just 3. Over here 9 minus 5, which will, see, 9 minus 4, which will be 5. So 5 minus 1. Okay. So we have got here. You can just write it as 5. Okay. So here I can write it as 5, here I can write it as 3, just like that you can leave it. Okay, so if I'm just plotting it, if I'm just plotting the graph, over here I can just assume that this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is enough. So see, what is the x value that I have given? 1 is something that I have given. So for 1, what I've got 3. So 1, 2, 3. Then for x value, which is 3, what I've got? I've got 5. So 4, 5. So for x value 3, I've got 5. Okay, so we want only 2 points. Okay, in order to determine a line, we want only 2 different points. So I've got here 2 different points. Now I can just plot it. So this is how the line is. This is how the line is. Okay, so why haven't I taken here 2? Why haven't I taken here 2? Many of you guys would have guessed why haven't I taken here 2. Now we will check what happens if I take over here 2. Okay. This is the place where when I take 2, that is the place where we use this limit. So f of x is equal to x square. So in place of, first so x is equal to 2 now. X is equal to 2. So f of x is equal to 2 to the whole square minus 4 whole divided by 2 minus 2, which will be 0 by 0. Okay, so whenever you are getting 0 by 0, infinite by infinite, such sorts of forms, or 0 by infinite or infinite by 0, such sorts of forms, then that form is known as ID format. Okay, so this is known as ID format. So that means it is indeterminable format. Okay, you cannot determine it. Okay, we don't know what is 0 by 0. We don't know what is infinite by infinite. We don't know what is infinite by 0. We don't know what is 0 by infinite. Such sorts of expressions, we don't know what the value is actually exactly. So what we will be doing is, normally in this place, what you have to do is, we will be giving input values near to 2. Okay, we will be giving input values nearer to 2, but it will not be 2. For an example, if I give 1.9, okay, if I give 1.9 as x value, okay, so I will just write. So x values I'll write here. So then after function, I will be getting some y values, right? That will be, I will be writing here. If I write here 1.1, okay, yeah, 1.9 as the x value, then the f of x value will be 3.9. Okay, and if I give here 1.99, then it will be 3.99. If I give here 1.999, then it will be 3.999. Like that, as you bring this x value closer to 2, closer to 2, that means this y value will be also coming closer to 2. So actually here in this case, you are not giving the exact value of 2. Okay, you are not here giving the exact value of 2. Instead of that, you are giving the values which are nearer to 2. So in that case, it is, see, the x values are approaching towards 2, right? From this side, it is actually approaching towards 2. You can also give, okay, you can also give it as 2.1, okay, 2.1, and you can substitute in this format. Then also you will be getting something around 4 point something 0000, something like that one you will be getting, or 01. I think it will be 4.01, like that only you will be getting. Okay, it will be also nearer to 4 only. So when you are putting values from this side to this side, okay, so when you are putting values from okay, when the values are approaching towards 2, like this side can be, or also this side it can be, in that time the values will be also approaching in the y-axis also. Okay, I think it's not, the spark isn't getting. As I give the values towards 2, the values, okay, see, you can just see that here values, as I approach 2, here as I approach 2, the values over here are approaching towards 4. That means if you put over here 2, then that means the value that is being approached will be 4. Okay, so as these values approach towards 2, they will be also approaching the value that is in the y-axis. That is what here it is saying. Okay, that is what here it is being said. So since you cannot write like this, okay, you cannot do like every time like this and then you cannot do. So what we people normally will do is to represent like this, okay, to represent formats like this, that the value is actually approaching, all those things we have to represent, right? So we have started to use the notation called the limit. Okay, so limit. So here how will you express it? So since limit, and here what is the value? That is 2. So since all the values in the x-axis are approaching towards 2, you have to write that x-axis values are approaching towards 2, and then you have to write the function. That is, this is what the function is. So x squared by 4 whole divided by x minus 2. Okay, so like this you can represent. I will just give the same sentence another time with a little bit modifications. Okay, so that you can just get it. See, as these x values just approach towards 2, then you will be also getting some values that will be approaching towards a number that is in the y-axis. So the approachable number which is in y-axis is where this 2 is approaching. I'll just try one last time to express the sentence, okay, in different way. See, as you give values, as you start to give values to this function, okay, so this is what the function is. To this function I am giving a value that is 2. Okay, so when I have given 2, it comes 0 by 0. So we cannot understand, or we cannot find what is 0 by 0. Okay, so this is known as indeterminate form. So that means like this you cannot find the value. Now what mathematicians have did is they have started to use some other techniques. That is what the limit is. Okay, that is where the limit is. Here if you are just checking, so since it is indeterminate form, so here is the place where limit is existing. So you have to find, what will happen to this function if I give 2. What number will this function have if I give in this place 2? In place of x, if I substitute 2, then what will happen to this function? That's a question that many of us will have. Even mathematicians have. So what they did is they have introduced the concept of limit. So that by using this concept, you can easily solve functions, okay, without actually giving the input value, So here you are not actually exactly you are not uploading the value of 2. You are uploading the value which is around 2. Like see 1.9, 1.99, 1.999 or 2.1, where all these can be rounded off to 2. So in this time, if you are uploading these values, then as output you are getting these values, which is 3.9, 3.99, 3.999, then 4.01. I don't know whether this value is correct or not, 4.01. If it is correct, okay. If it's not correct, you can put it in the calculator. So yeah, so these are the values that it is approaching. As the value that you give to 2, okay, instead of 2 you are giving these values, right? So these values are actually approaching towards 2. Like that, these values are also approaching towards a specific number in the y-axis. The number which is being approached in the y-axis is what actually known as the output. So for 2, the output is 4. So for 2, the output is 4. See, for 2, the output is 4. So instead of actually uploading the value, you can do it like this. Okay. But in class 11th, what we did is that limit space won't be enough. So I'll try to write it over here. Okay. So limit. I'll use another color. So let it be this color. So limit x approaches to 0, the same function is there, right? Okay, I'll write it here even. Limit x approaches to 0, where this one sentence, this one expression can be, okay, this numerator can be expressed as x minus 2 and x plus 2 whole divided by x minus 2. Okay, so like this you can express it, right? So this one and this one can be cancelled out. Which one and which one? This one and this one and this one can be cancelled out. Then what you will be having, you will be just having limit x approaches to 2. So here x plus 2. Okay, so in place of x, if you are substituting now 2, you will be getting 4. So that means in place of x, if I substitute 2, then that will be 2 plus 2, which will be 4. Okay, that is what 4 is. In class 11th, we have studied about this. Yes, right? So this is what actually the limit concept is. I hope you can understand them. If you cannot, don't worry. This is not the one and only video that is available in YouTube. There are n number of videos. Even I am hoping that even in your own mother tongue, you will be having videos based on this limit concept. You can just check out them. But that's not that important for class 12th. But if you just understand, I personally felt like it will be good. Okay, so it would be good. Okay, so now coming to this case. In this case, I will just give you some basic knowledge about this lesson first. In this lesson, they will be giving a function. Okay, they will be giving a function. From here, if you are starting to take notes now, it will be perfect, I think. Okay, so there will be a function. As I said, that every function will be having its own graph. So let us assume that the graph is like this parabola. It need not be a parabola, but there is a graph like this. Okay, and there will be a specific point that will be asked by people. Mathematician in question paper set is. Okay, for an example, let that be this point. Let it be this specific point. Okay, so I will first mark the numbers 1, 2, 3, 4, or let this be point A. Okay, let this be point A. Okay, so this is point A. So see, which means this graph actually means that in this point, in this every point, it is continuous. Okay, in this every point also it is continuous. They are asking us to find whether is it continuous at this point or not. Okay, so this is also about limit only. Well, see, this is that particular a value, right? So when you give this value, when you give f of c, there is a function. Let's take that there is a function. Okay, so f of x is the function. This is what the function is. Or okay, so there will be some function. Some function is there. Okay, there is some function. For that function, this is what the graph is. Okay, so to that function, you are giving this a value. When you are giving this a value, then you are actually having some definite value even in y-axis. Okay, so after that, you have to know that from this point. Okay, so this is what the graph of the function is. Okay, so from this point to this point, it is continuous. It is always continuous. Okay, and also from this point to this point also, it will be always continuous. That also you have to know. So these are those two important things that you have to know. Okay, so the point that is coming from here, okay, from here to here, right? So this is to the left side of the A. So this total thing is represented as this total thing till here, okay, except A. Other than A, it is represented as A minus. Okay, it is represented as A minus. Then from here to here, this total last. So other than A till to the last, it is represented as A plus. Okay, exactly at A. Okay, exactly at A is what it is A. Okay, so as I've said that this point, okay, at this point, okay, at this point, okay, A minus and A plus, it is continuous. It is continuous, but at the point A is the question. But at A, what is at A? Whether is it continuous or whether it is not continuous is the question. Okay, so to say whether it is continuous or not, there are three conditions that has to be met. Okay, ma'am. So those three are, well, Okay, so I will say those three very clearly. First condition, wait, I will first say now. That is f of x, or here since it is a, so f of a I will take it is definite. So that means if you are giving this a value to this function, okay, to this function, then that means it should be giving you some sort of definite value in this y-axis. That is what it actually means. Okay, so this is what the first condition is. Okay, so that means f of a is actually definite. This is what the first condition is. So when you are giving a value to this function, it automatically gives you some value in f of x. Okay, so the second condition is that you have to take about the limit. Limit exists. Limit exists. Okay, so this is what the second condition is. Then the third condition is limit. Okay, limit should be equal to the result of the function. Limit should be equal to the result of the function. Okay, so this is what all these things are. So this can be also said as limit x tends to a where f of x exists. Okay, this is existing, and also for this I can say this as limit x tends to a is where f of x is equal to f of a. Okay, so this is what actually this is in terms of sentence, this is in terms of mathematical expression. Okay, then yeah, so this is what it is. This is what continuous is. To be continuous, if these three following points are being met, okay, if these three conditions are being met, then we can say that it is continuous. First, what is it? It is that if you are giving this particular value of a to a function, and if that function is giving you some other value in return, okay, then we will be saying that as the first condition. Okay, that is f of a is different. Okay, this is what the first condition is. If it is being met, okay, then we have to check the next condition, that whether the limit exists or not. Okay, if the limit exists, then it is what the second condition is. So to check whether the limit exists, like this I have said, right? So here limit is 4, so that means here it does exist. Next, so in which case, or how to determine whether the limit exists or it does not exist? This is a very common doubt. Okay, limit. Okay, so yeah, x tends to minus a. That means there will be this limit, right? Okay, it has a function. It has a particular function. We can say that this function is actually f of x. Okay, f of x. Okay, so that means till this point to this point you are just putting some values and then you are just coming. From here to here you are putting some values and then you are coming. That is what here it says. Okay, minus. So for this you are putting and then you are getting some definite values which are these points. So as you come like this, it also comes like this. Okay, so that is what it actually means. It should be equal to, from this side you are coming, right? So that should be equal to from this side. Okay, so that means it should be equal to limit x tends to a plus f of x. Okay, so that means if you are giving values from this side, it should be coming like this. If you are giving values from this side, it should be going like this. Yeah, like this you can take. Actually, the thing is, it need not to be like if you are coming like this, then it should be coming like this one. It need not to be like that. It can also come like this. It depends upon the function. Or just the key point is that if you are coming like this, then that means this value has to be approached. This particular value, okay. So here this value has to be approached. If you are coming like this also, then that means that this value has to be approached. That is the point. Okay. So to say that whether the limit exists or not, you have to use this one, f of x. Okay. Then so this is actually for second point. Okay, so for this point only this is. Next, limit is equal to result of the function. Yes, so you have to check whether the limit is equal to result of the function or not. If the limit value is 4 and also the resultant value of the function is also 4, that means it is continuous. Which means here, see, here what we have done, we have given the limit which is 4, okay, here which is actually 4, and here see it is actually f of x. In place of this x, if I just directly substitute 2, then what will be happening? It means that automatically here will be 0 by 0, which means here it is not equal. Okay, here it is not equal, that means it is not continuous over here. It is not continuous over here. Okay, like that when we will be doing a very specific sum. So before that, I will say some points very clearly. Okay, here I personally feel like I haven't said everything clearly. I've said mostly, but it's not that clear. So now we will check about everything very clearly. Okay, see, so continuity. What are those 3 steps? First step is same only. Okay, where f of a exists. Okay, so f of a exists, that means it is definite. Okay, so here that one, a very clear explanation I have given. And the second thing is that, okay, limit should exist. Note it, we are talking at a, okay, we are talking only at a. All the things that I am saying, right? So that is x is at a. Okay, so x is at a. So here also we can say that, very important, x is at a. Okay, so it should be, it says that limit exists, so which can be said as LHL, left hand limit, should be equal to right hand limit. If this is met, if this condition is met, then that's okay. So which means that limit where x tends to a minus, okay, f of x should be equal to limit where x tends to a plus f of x. Okay, then only it is said as limit exists. Okay, so if it is like this now, then you can directly write. Okay, then you can directly write it as limit x tends to a, okay, f of x. Limit x tends to a, f of x. That is what it means. Is equal to some L value. Here also it will be equal to some L value. Okay, so yeah, that's it. So see, if you are substituting in place of x, if you are substituting this a value, you will be getting some value. Let us keep that value as L. Here also, in place of x, if you are substituting some value of a, this a plus, then you will be getting some value. So these two values should be equal, which is L. Then that automatically says that this total limit is equal to L. Okay, so this total limit is equal to L. Everything is based on class 11th limit only. Okay, so if you are strong in class 11th limit now, then this lesson will be easier for you than others who are not strong in limit. I'm not saying that I'm very strong in class 11th limit. I did some hard work in class 11th limits, so we can say. Okay. Next, third condition. Third condition is there. That is f of a. That means the function. Inside the function, you have to directly substitute this a value. Inside this function, you have to directly substitute this a value, and then you have to check. Okay, if you just directly substitute inside this function this a value, and if you are getting the resultant value as L, then that's okay. Then there is no problem with that. Pakka, superb, amazing. Then we can just say that okay, it is continuous. But if in case it's not equal to L, if it is not equal to L, then in that case here continuity does not exist. Here continuity does not exist. Okay. In many points, okay, in many places, many of us may have some problem in this point. Okay, in this point, that is in this L. If this L value is actually what? 0 by 0 or infinite by infinite. Okay, just 0 by 0 or infinite by infinite. If this is 0 by 0 or if this is infinite by infinite, then we have to use some other methods in order to simplify it. What are they? Namely, we can say which color, this color, this color. Okay. That will be, we can just use, just we can simplify. Okay, we can just simplify the equation, simplify the function. Okay, the function. Okay, simplifying in function in sense like how, see, we have got this one, right? Okay, see, we have got this function, right? I've simplified it into like this, then into like this, then we have got like this, right? Like that. You can just simplify this function. That is what it was the greatest part in class 11th itself for simplifying this function only. For me, my brain had got twisted while doing this. Okay, I'm not that good in mathematics like others. I'm not naturally talented. Just have to do hard work. Then only I'll be getting into my mind somewhat. Okay, so yeah, so you have to first simplify this function. For this, you want a lot of experience, which I don't at all have. Okay, so next is you can use L'Hopital rule. For this, you don't want that much of experience, and it is just a shortcut trick, I can say. Okay, or it is just or. But unfortunately, it is not in our portion. Maybe if it had been in our portion now, then we would have felt this lesson as very easy. Okay, but don't worry. In 10 to 15 minutes video, I will be putting also L'Hopital's rule. Okay, so after that, you have to use, this is what, now the thing which I'm going to say is what very important. Okay, that is LHL and RHL, you have to separate. For an example, okay, or, one second, just some uplift. Oh god. Okay, so or this one, which is, see, in place of LHL. Okay, so in place of LHL, what you have to do is, you have to substitute that x is equal to a minus h. Okay, x is equal to a minus h. That means in place of this x, what you have to substitute? You have to substitute a minus h. Then at last, which will be giving you h tends to, okay, h tends to 0. H tends to 0 in LHL. I know it doesn't make any sense. Okay, just forgot that substituting thing. In LHL, in place of x, you have to put a minus h. That means in place of f of x, in place of f of x, for an example, there is a function which has x in it. So in place of this x, you have to substitute this a minus h. Then you will be getting. Okay, so this is in LHL. Then what about in RHL? Then you have to substitute over here x is equal to a plus h. Okay, where h will be tending towards 0. Okay, so here it will be a minus, right? So here you are putting a minus h. Here will be a plus, right? So that is why you are putting here a plus h. Like that you can keep it. Okay, so for our convenience, we will be doing 1 or 2 sums based on this total concept. Okay, so exercise 5.1. Exercise 5.1. First question. What is this first question? F of x minus 3. Okay, f of x is equal f of x minus f of x is equal to 5x minus 3. This is what the first question is. So now we have to check whether it is continuous or not. Okay, whether it is continuous or not. I like green color, so I will be solving in green color itself. No, white color. So I like white color. I will be solving in white color itself. So first condition is what? This f of a exists. Yeah, that is what the first condition is. But to prove it, okay, to prove you need not to say you need not to prove that f of a exists. Okay, that you need not to prove. What we'll be doing is from second step and third step only we'll be taking. Okay, second step and third step only we will be taking. Okay, and note that this limit should be equal to this function's value. Okay, that I have said, but I have not written it. If you cannot get anything into your brain, if you're feeling like, oh god, it's all confusing, it's all collapsing, do not worry. if you watch sums automatically you will be getting it, or just watch this video again from the beginning without writing anything, just listen, you will be getting all the concepts. Okay, so f of x minus 3 is the thing. So what is the first condition? First we have to check whether the limit exists or not. So here they have given in the question itself at x is equal to 0. That means limit x tends to 0. This one you have to write f of x minus 3 you have to write. So now what you have to do, in place of this x you have to substitute this 0. Okay, so now if I substitute 0 minus 3 is equal to minus 3. Okay, so this is what the value that I have got. Okay, so at x is equal to 0. Perfect. So this is what you have to take as equation 1. Okay, then equation 2, what you have to do is you have to directly substitute. Okay, in place of c, if this is what f of x is equal to 5x minus 3. Okay, so you have to directly substitute f of 3. Okay, f of 0. I'm so f of 0 is equal to 5. 0 minus 3 is equal to minus 3. Okay, so this is what equation 2 is. So you have got these two equations. Okay, so we can say that equation 1 is equal to equation 2. So from this we can say that limit x tends to 0, f of x is equal to f of a. Okay, is equal to, sorry, f of 0, which is not a is what actually is 0. So f of 0. Okay, so you can say that it is continuous. It is continuous. Okay, it's just continuous. Okay, oh god. It was just brain glitch. Okay, so it is continuous. Yeah, so this is how we will be doing. Okay, so I've said all the concepts. Like other lessons like determinants or like matrix at all, we cannot just we cannot just do 1 or 2 sums and we cannot just complete this lesson. For this lesson we have to do each and every sum and we have to try. I hope in your mother tongue even there will be a lot of videos where they have put sums one by one, so you can see them, or I will try to put sums, but I don't think I can. I'll try my level best. Okay, so thank you, bye bye. We'll meet in another amazing video. Bye.